Hello friends, now we will start the second exercise, exercise 1.2. I will explain all the first basic and examples, illustrative examples, and then we will start the exercise 1.2. Now let us start. The empty set. Consider the set A is equals to, in curly bracket, X is such that X is student of class 11 presently studying in a school. We can go to school and count the number of students presently studying in class 11 in school. Thus, the set of A contains a finite number of elements. We now write another set B as follows. B is equals to X is such that X is a student of presently studying in both classes 10th and 11th. We observe that a student cannot study simultaneously in both classes 10th and 11th. Thus, the set B contains no element at all. Okay. Now the next definition. A set which does not contain any element is called the empty set or the null set or the void set. According to this definition, B is an empty set while A is not empty set. The empty set is denoted by symbol phi or empty curly bracket. We give below a few examples of empty set. First example, let A is equals to, in curly bracket, X is such that X lies between 1 and 2 and X is natural number. But we know that there is no natural number between 1 and 2. Then A is an empty set because there is no natural number between 1 and 2. This first example. Second, B is equals to X is such that X square minus 2 is equals to 0 and X is a rational number. Then B is empty set because the equation X square minus 2 is not satisfied any rational value of X. Okay. Now the next is third, C is equals to X is such that X is an even prime number greater than 2. We require the even prime number. Then the C is again empty set because 2 is only the even prime number. Okay. And here X square minus 2 is equals to 0. X is a rational number. If we solve it, then you will get X square is equals to 2. And if we take its a square root, then X is equals to plus or minus root 2. And root 2 is irrational number, and therefore this is not possible. And therefore the B is an empty set. Now next is D is equals to X is such that X square is equals to 4. X is odd. Then D is empty set. There is no odd number whose square is 4. Then the D is empty set because the equation X square is equals to 4 is not satisfied by any odd value of X. Now the next. Finite and infinite sets. Let A is equals to, in curly bracket, 1, 2, 3, 4, 5. D is equals to A, B, C, D, E, G. Next, and C is equals to men living presently in different parts of the world. We observe that A contains 5 elements, B contains 6 elements. How many elements does C contain? As it is, we do not know the number of the elements in C, but it is some natural number. We can count it, which may be quite a big number. By the number of elements of the set S, we mean the number of distinct element of the set, and we denote it by n of S. That is, we can count the number of elements of the any set. Okay, and it is denoted by n of S. If the n of S is a natural number, then S is non-empty finite set. Consider the set of natural numbers. We see that the number of elements of this set is not finite, since there are infinite number of natural numbers. We say that the set of a natural number is infinite set. The set A, B, C given above are finite set. That is, n of A is equals to 5. Number of the element in set A is 5. N of B is equals to 6. And n of C, there is some finite number. We can count it. Okay. Now the next definition. A set which is empty or consists of a definite number of elements is called finite. Otherwise, the set is called infinite. Consider some examples. First example, let W be the set of days of the week. Then W is finite. It's clear. Let S be the set of solutions of the equation x square minus 16 is equals to 0. Then clearly S is again finite, because the solution set contains plus or minus 4. Let G be the set of points on a line. Then the G is infinite. We cannot count that points on the line. When we represent a set in a roster form, we write all the elements of the set within the braces in the curly bracket. It is not possible to write all the elements of the set, all the elements of an infinite set within the braces, because the numbers of the elements of such a set is not finite. So we represent some infinite set in the roster form by writing a few elements which clearly indicate the structure of the set, followed by or preceded by 3 dots. For example, 1, 2, 3 and 3 dot is here is the set of natural numbers is the set of 1, 2, 1, 3, 5, 7 is the set of odd natural numbers dot 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 minus 3, minus 2, minus 1, 0, 1, 2, 3 and again 3 dot. The set of integers. All these sets are infinite. Now note that all infinite set cannot be described in the roster form. For example, the set of real numbers cannot be described because they may be the rational and irrational, okay, described in this form because the elements of this set do not follow any particular pattern. Example, state which of the following sets are finite or infinite. First, x is such that x belongs to set of natural number and in first bracket x minus 1 into second bracket x minus 2 is equals to 0. And if we solve this, then we will get x is equals to 1 and x is equals to 2. It's a solution. The given set in curly bracket 1, 2, hence it is a finite. Second, x is such that x belongs to set of natural number and x square is equals to 4. Solution. Given set, x is natural number and x square is equals to 2. Therefore, only the 2 is a natural number whose square is a 4 and x belongs to natural number. Therefore, this set is a finite. Next example. X is such that x belongs to set of natural number and 2x minus 1 is equals to 0. Therefore, the solution set. That is, if we solve this, 2x minus 1 is equals to 0. Means what? 2x is equals to 1. Okay. Therefore, x is equals to 1 upon 2. But 1 upon 2, half 1 upon 2 is not a natural number. Therefore, the given set is empty. Hence, every empty set is a finite. Now the next is x is such that x belongs to set of natural number and x is prime. Solution. The given set is the set of all prime numbers and since the set of prime number is infinite, hence the given set is infinite. Okay. We cannot count it and therefore it is infinite set. Now next, x is such that x belongs to set of natural number and x is odd. Since there are the infinite number of odd numbers and hence the given set is infinite. Now the next, equal sets. Given two sets A and B, if every element of A is also an element of B and if every element of B is also an element of A, then the set A and B are said to be equal. That is, the two sets have the same element. Clearly, the two sets have exactly the same elements. Then two sets are said to be equal. Definition. Two sets A and B are said to be equal if they have exactly the same elements and we write A is equals to B. Otherwise, the sets are said to be unequal. And we write A is not equals to B. This is the symbol for unequal. We consider the following examples. First, let A is equals to 1, 2, 3, 4 and B is equals to 3, 1, 4, 2. Then A is equals to B. These two sets are equal, though their order is not equal. not same. Second, let A be the set of prime numbers less than 6 and P the set of prime factors of 30. Then A and P are the equal. Since 2, 3 and 5 are only the prime factors of 30. Okay. And also these are less than 6. And the first set A is a set of prime numbers less than 6. Means we will get 2 is a prime number, 3 is a prime number and the 5 is a prime number. That is set A contains 2, 3, 5. And the P is the set of the prime factors of 30. And then prime factors of 30 are 2, 3 and 5. Therefore these two sets are the equal sets. Note, a set does not change if one or more element of the sets are repeated. For example, A is 1, 2, 3 and B is again there is a repetition. These are the equals since each element of set A in B and vice versa, that is B is in A. That is why we generally do not repeat any element in the describing a set. Okay. Next example. Find the pairs of equal sets if any given reason. Give the reason. A is equals to in curly bracket 0 and B is a set such that X is such that X is greater than 50. And what is that? X is less than 5 also. C is equals to in curly bracket X is such that X minus 5 is equals to 0. Now see this here. D is equals to X is such that X square is equals to 25. Now X is such that X is integral positive root of equation X square minus 2X minus 15 is equals to 0. Now see this is the solution. Since A has 0, okay, and 0 does not belongs to any of the set which is B, C, D, E. It follows that A is not equals to B, A is not equals to C, A is not equals to D and A is not equals to E. Next, we'll take the B. What type of the B set? He says that X is greater than 15 and X also at the same time X is less than 5. But no of the other set are the empty. B is empty set. And the all other sets have the some elements, that is the C has some element, D has and E also has. Therefore, B is not equals to C, B is not equals to D, B is not equals to C. Okay. And next is C. This is the set. X is such that X minus 5 is equals to 0. Then for X is equals to 5. Okay. C has the only the element 5. But what is that? In D, X is such that X square is equals to 25. Therefore, in the D, we have the two elements. That is the 5 and minus 5. Okay. Minus 5 belongs to D. And therefore, C is not equals to D because C has only the 5. And D has two elements. That is 5 and minus 5. Therefore, C is not equals to D. Next. That is the E. This is the set. We have the, if we see this set, E. We solve this quadratic equation, x square minus 2x minus 15 is equals to 0. Then we have, that is the factors are in first bracket, x minus 5 in second bracket, x plus 3, and if we solve it, then we will get, that is x is equals to 5 and x is equals to minus 3 and therefore the E set has only the 5 element and C has also the 5, and therefore these two C and E both are the equal. Okay. What about the D? D has the 2 element, minus 5 plus 5. He has only the 5. We find that the D is not equals to E. D is not equals to E. D has the 2 elements. Okay. Thus, only pair of equal sets is a C and E. We have only here, see this here. C has the 5 element and E has also the 5. Therefore, C and E are the equal sets. You can find out it. Okay. Now the next example. Which of the following pairs of sets are equal? And justify your answer. You can find out also it. X, the set of letters in alloy. Again, I will repeat. X is a set of letters in alloy. And B, the set of letters in loyal. Okay, I will repeat again here. B is the set of letters in loyal. Next example. A is equals to, in curly bracket, n is such that n belongs to set and n square is less than or equals to 4. And B is equals to, in curly bracket, x is such that x belongs to set of real number and x square minus 3x plus 2 is equals to 0. Now the solution. We have x is equals to, that is a L L O Y, and B is equals to L O Y L. Then the set A and B are the equal sets as the repetition of the elements in a set do not change the set, and thus x is equals to A L O Y and B is equals to, both are the equal. What about the next? That is, n is such that n belongs to set of integers z, that is n square is less than or equals to 4. Okay. Then we have the numbers. It is a minus 2, it's a square, is less than or equals to 4. Minus 1, it's a square, less than or equals to 4. 0, 1 and 2. What about the B? X belongs to set of real number and x square minus 3x plus 2 is equals to 0. If we solve that quadratic equation, the factors are, in first bracket, x square minus 3x plus 2 is equals to 0 are, in first bracket, x minus 2, second bracket, x minus 1. And then we have the elements 1 and 2 in the set B. Now see these two sets, that is a 0 belongs to A, but the 0 does not belongs to B. Therefore, A and B are not equal sets. I will start the exercise 1.2. Which of the following are the examples of null set? That is, set of odd natural numbers divisible by 2. A set of odd numbers divisible by 2 is a null set because no odd number is divisible by 2. Set of even prime numbers. A set of even prime number is not null set because 2 is an even prime number. Next, x is such that x is a natural number and x is less than 5 and x is greater than 7, both of these, and this is not possible again. That x is such that x is natural number and it is less than 5 and greater than 7 also, and this is the null set because a number cannot be simultaneously less than 5 and greater than 7. Y is such that y is a point common to any two parallel lines. There is no point common to parallel lines because they never intersect. Y is a point common to any two parallel lines is a null set because parallel lines do not intersect. Hence, they have no common point. Which of the following sets are finite or infinite? We can easily determine it. The set of a month of year. It's clear that we can count it. The set of month of year is a finite set because it has 12 elements. Second, 1, 2, 3 and dot dot 3 dots. And this is the infinite. Is an infinite set as it has infinite number of natural numbers. Next, 1, 2, 3 up to the dot dot 3, 4 dot and 99 up to the 100. And this is the finite. Okay, is a finite set because the numbers from 1 to 10 square are the finite in number. Next, the set of positive integers greater than 100. The set of positive integers greater than 100 is an infinite set because positive integers greater than 100 are infinite number. Next, the set of prime numbers less than 99, you can count it, it's a finite. The set of prime numbers less than 99 is a finite set because the prime numbers less than 99 are the finite in number. State whether each of the following set is a finite. Now again I will repeat here. State whether each of the following set is a finite or infinite. There will be the mistake in this question number. Let it be. The set of lines which are parallel to x-axis. Let we have infinite number of the lines which are parallel to x-axis. The set of lines which are parallel to the x-axis is infinite. Said because the lines parallel to x-axis are infinite in number. Next, the set of letters in English alphabet, it's a finite set. The set of letters in English alphabet is because it has only the 26 element. Next, the set of numbers which are multiples of 5. Now this is infinite. The set of numbers which are multiple of 5 is an infinite set because the multiples of 5 are infinite in number. Next, the set of animals living on the earth. The set of animals living on the earth is a finite set because the number of the animals living on the earth is finite, although it's a quite a big number. The set of circles passing through the origin, it's an infinite set because we can have the number of the radius, that is radius may be the different. The set of circles passing through the origin 0, 0 is an infinite set because the infinite number of circles can pass through the origin. In the following state, whether A is equals to B or not. The first set contains A, B, C, D, and the B is a D, C, B, A. Yes, these two sets are equal because both of them have the same elements, though the order is different. The order in which the elements of a set are listed is not significant, and therefore A is equals to B. Next, A has that is a 4, 8, 12, 16, and B is 8, 4, 16, and 18. These two are not equal because B has 18, A has not 18, and therefore these two are not equal. 4, 8, 12. 12 is not also in B, and you can determine it. These two sets are not equal. It can be seen that the 12 belongs to A and 12 does not belong to B. Therefore, A is not equals to B. Next. A has the element 2, 4, 6, 8, 10 and B. X is such that X is a positive even integer and X is less than or equals to 10. Okay. Now, A has the element 2, 4, 6, 8, 10 and the B. X is such that X is less than or equal to 10. That is a 2, 4, 6, 8, 10. Therefore, A is equals to B. A is equals to X is such that X is multiple of 10 and B is 10, 15, 20, 25 and 30. Now, again these two sets are not equal. Today, X is such that X is a multiple of 10. Therefore, B has 10, 15, 20, 25, 30. It can be seen that 15 belongs to B and 15 does not belong to A. Again, these two sets are not equal. Now the question number 5. Are the following pairs of sets are equal? Give reason. The first is A is equals to in curly bracket 2, 3, B is equals to in curly bracket X is such that X is a solution of X square plus 5X plus 6 is equals to 0. And if we solve this quadratic equation, the factors are X square, which is the solution of X square plus 5X plus 6 is equals to 0. This solution set has the, that is in first bracket X plus 2, second bracket X plus 3. Therefore, we can factorize it. And if we solve it, then we will get X is equals to minus 2 and X is equals to minus 3. And A has the element 2 and 3 and B has minus 2, minus 3. Therefore, A is not equals to B. Next, A is equals to in curly bracket X is such that X is a letter in the word follow. Y is a letter in the word wolf. And the solution set X is such that X is a letter in the word follow, that is F O L W, and B is a Y is a letter in the word wolf, and therefore we have W O L F, same number, same elements. The order in which the elements of the set are listed is not significant, and therefore A is equals to B. These two sets are equal, they have the same elements. Next, from the sets given below, select the equal sets. You can also find out it. A contains 2, 4, 8, 12. B has 1, 2, 3, 4. C 4, 8, 12, 14. C 3, 1, 4, 2. E minus 1, 1. F 0, A. G 1 minus 1. H 0, 1. Now, the A has the element 2, 4, 8, 12. And B has the 1, 2, 3, 4. C has, these are the elements. You can do it this way. It's a very simple question. Which have equal sets. Okay. Here is H, by mistake it is written as. You can also determine the which sets are equal. It can be seen that it belongs to A and it does not belongs to B, D, E and F, G, H. Therefore A is not equals to B, A is not equals to D, A is not equals to E, A is not equals to F, A is not equals to G, A is not equals to H. In this way you can. Next, also 2 belongs to A and 2 does not belongs to C, and therefore there is here A is not also equals to C. Similarly, we can find out it or show that we can show that E is not equals to F, E is not equals to G, okay, and E is not equals to H. Next, F is not equals to G, F is not equals to H, and G is not equals to H. By the observation, you can write the answer of this question. It's very simple. The order in which the elements of a set are listed is not significant. One thing is that we can find out which are the equal sets, and then remaining all are not equal. Okay. Here B is equals to D. B and D, these are the equal sets. B has the element 1, 2, 3, 4, and the D has 3, 1, 4, 2. Okay. And E and G, if you see this E, here is the E minus 1 and 1, and G 1 and minus 1. These two sets are equal sets. And here in this here, that is the B is equals to D and E is equals to G. Okay, and in this way we have completed the exercise 1.2. Now we'll see in the next video. Till then, goodbye.